Okay, we got a customer up in Lancaster, commercial building. They've had ice issues with ice backup coming in on that back wall. There's a drop ceiling in there, 2x2 tiles, and about 6 inches above that is a fiberglass insulation, no harmonic seal between the two. They got heating units up in the attic, and air conditioning over on this side. You can see the vent for the condensation here, and a heating unit there with a lot of ductwork. Big open, 2 foot on center trusses. If they wanted to stop or arrest this ice, the real solution would be a good 4 inches of foam on the bottom of the roof deck, because there's too many obstacles to try to separate the living area from the attic space with the units in the attic. So this is all big and open, and everything from that end cap of that gutter, that end cap of that gutter is filled with ductwork and heating units. So what we're gonna propose is at least some ice control, and giving them an option of a 220 or a 110 feed. Our cost isn't going to be any different for our wire. The cost would be the power hookup, and what we need is a dedicated, at least minimum 20 amp. Might even, once I get the footage done, for this amount of footage we might want a 30 amp in here. So I did misspeak. I should have informed them of that. So we've got a good 2 foot overhang on this back gutter. Gutter's going to come off. We want to put a 6-inch gutter and a 3x4 downspout, and so we got more relief for all this roof area. There's a lot of square footage of roof. We'll run 1 pass in the gutters and the downspouts, and then 2 passes in the helmet, and then where this big overhang is, we're going to want to go 2 feet up the roof, so we can run our warmth up to the heated areas. So whatever warmth is coming through the living area or the work area, it won't freeze before it gets to the edge. So we want to keep that lukewarm and off the roof. You'll see some small icicles hanging over the nose of the helmet. Depending, if we get 15 below zero, you're going to see some ice. It's not going to be anywhere near what you got. And of course, the object here is your first snowfall, you turn the system on, and at the end of the year, you turn it off. As long as there's snow on the roof, you want to keep this bottom edge lukewarm. So we're looking at doing this inside cove here, and then we got 2 sections above this porch railing here at this side entrance. We want to replace these and put helmet in here. This has got its own 110. Now this might be worthwhile to. And if it ties into that line that's over there, maybe segregate that line, turn that to a 220, leave your 110 here, and utilize it for this area here. But it has to be hardwired. We won't do a plug. So, and I'm going to give them an option just to change this gutter and put helmet up here, because this is an eyesore, and I know this is just shooting over. It's not working at all. It's one of those vinyl louvered unit systems that they have here. So we're going to look at these 3 gutters here with their downspouts. Helmet heat separated. We won't have to weave because we don't have a big overhang here. And then this inside cove back here, we won't have to weave on the short overhangs, but we will have to weave on this larger overhang. And then of course we always go up the valley a couple of feet. And that would at least get their ice under control for the winter months, and help stop any ice backup from getting into the building itself. Okay, so that's what we're here to do, solve the problem.